All right, let's talk about one of the biggest, most expensive questions in business. When you do something, how do you really know it caused the result you're seeing? It's time to put on our detective hats and figure this out.
Okay, picture this. You just launched a slick new ad campaign. A month later, your sales are up 10%. That's great, right? But was it actually the ad? Or maybe your biggest competitor just ran out of stock? Or maybe the economy got a little better? Could it just be a random coincidence? Answering that question correctly is worth millions, sometimes even billions of dollars.
You see, to get to the real truth here, we can't just make an educated guess. We've got to be methodical. We need to gather evidence, follow the clues, and, most importantly, rule out all the other possibilities. So for the next few minutes, we're going to approach this like a detective story, investigating the super tricky world of cause and effect.
Now, any good detective operates by a code, right? A set of rules they live by to make sure they find the truth. Well, when we're trying to find causality, it's pretty much the same thing. There are these core principles that we absolutely have to follow if we're gonna prove our case.
And the first rule is a big one. You know, unlike in a simple high school science experiment where you mix A and B and you always get C, the business world just isn't that clean. It's messy. We're not looking for one single thing that guarantees a result. What we're really looking for are actions that make a good outcome more probable. So the question isn't, did our ad cause sales to go up? It's, did our ad make a sales increase more likely? That's a huge difference.
So, to prove our case, our investigation needs to check 3 boxes. First, the thing we think is the cause and the effect we're seeing, they have to move in sync. Second, the cause has to happen before the effect. I know, it sounds super obvious, but you'd be surprised how often that gets mixed up. And third, and this is the really tough one, we have to eliminate all the other possible explanations.
Let's take a quick look at that first rule, concomitant variation. All that means is that the cause and effect vary together in a predictable way. So, for example, look at this table. It's showing a connection between someone's education level and how much they spend on high fashion. See how as education goes up, the likelihood of buying high fashion also goes up? The two variables move together. Now that's a clue. But, and this is key, it's just a clue. It's not proof because we haven't checked our other 2 rules yet.
Okay, so to do a proper investigation, a detective has to control the environment, right? They have to secure the crime scene. In research, that means we need to set up a real experiment so we can isolate our main suspect and see exactly what it does.
So first up, we have our independent variable. I want you to think of this as our prime suspect. It's the one and only thing we're changing on purpose to see what happens. In that sales example from before, the new ad campaign, that's our suspect. We're basically pointing at it and asking, did you do it? And what are we watching to see if our suspect did anything? Well, that's the dependent variable. This is the outcome, the result. It's the thing we measure to see if our suspect actually had an effect. This could be anything: sales, market share, customer happiness, you name it. Its value depends on what our suspect did.
Now this is how we isolate that suspect. It's absolutely crucial. We need 2 groups. The test group is the one that gets exposed to our change. They're the ones who see the new ad. But just as important, maybe even more so, is the control group. They see nothing. They don't get the ad. They just go about their business as usual. They are our baseline, our reality check. Without them, we have no idea if any changes we see were because of our ad or something else entirely. We'd be flying blind. Okay, so even the sharpest detectives can get thrown off the scent by false leads. In the world of experiments, we call these extraneous variables. And let me tell you, they can completely wreck your investigation by giving you other plausible explanations for what happened.
And here are some of the usual suspects when it comes to false leads. History is when some big outside event happens that you didn't plan for, like a competitor suddenly having a massive sale. Maturation just means that people change over time, all by themselves. Selection bias is a huge one. That's when you mess up and your test and control groups weren't really similar to begin with. And mortality is when people drop out of your study, and if more drop out of one group than the other, it can seriously mess up your results.
So here's the bottom line. If you don't control for these false leads, your evidence is basically contaminated. You can't be sure your suspect is the one who did it, and your whole case, your whole investigation could just fall apart.
So, how do we avoid all these traps? How do we get a clean conviction? Well, we need the absolute best investigative technique there is.
We need to design an experiment that controls that crime scene perfectly and leaves zero room for doubt.
You know, a lot of simple business investigations are actually pretty flawed from the very beginning. They might only look at one group, or maybe they don't have a proper control group. We call these pre-experimental designs. And honestly, the results you get from them are more like circumstantial evidence than solid proof.
To really crack the case, we need to bring out the big guns. We need what's called a true experimental design. This is the absolute gold standard for proving cause and effect. Think of it like the forensic science of the research world.
So what's the secret weapon here? It's random assignment. That's the R you see on the screen. By randomly putting people into either the test group or the control group, we can be super confident that, on average, the two groups are pretty much identical before we even start the experiment. This one simple move completely wipes out that huge false need we talked about, selection bias. It's a game changer.
So look, here's how we build a simple but incredibly powerful case. Our experimental group gets randomly assigned, that's R. Then they're exposed to our suspect, the ad, that's X. And finally, we measure the outcome, that's O1. Meanwhile, our control group is also randomly assigned, R, but they are not exposed to the ad, and we measure their outcome too, O2. It's simple, it's clean, it's elegant.
And now for the verdict. All we do is subtract the result of the control group from the result of the experimental group. That final number, O1 minus O2, that is the true isolated effect of our ad. Because we controlled the scene and because we used random assignment, we can be confident we've found the real cause. Case closed.
So thinking like a detective isn't just some clever metaphor. It's how you find real answers and make much, much smarter decisions. You now have the toolkit to go from just seeing a correlation to actually proving causation. The only question left is, what's the biggest why that you need to solve?